Hello, my name is Brianna, and today I'm going to talk about the different organs and the nerve plexus. So one organ that I chose that has dual innervation is the heart, and the heart has what is called antagonistic dual innervations. This is demonstrated by the heartbeat, and when the heart rate decreases, it's due to the parasympathetic nervous system, and when the heart rate increases, it's due to the sympathetic nervous system. The specific portion of the heart with dual innervations is the SA node, and the SA node functions as a pacemaker, producing action potentials in the heart and stimulates the rest of the heart to respond. So in this top corner, you can see I drew the heart with the little heartbeats happening. Then the main nerve plexus and territory of innervation, there's the cervical plexus, the brachial plexus, the lumbar plexus, and the sacral plexus. So the cervical plexus is at the ventricle rami of C1 through C5 and supplies the shoulder and neck. It innervates the diaphragm. The brachial plexus is at the ventricle rami of C5 through C8 and T1, and it consists of 5 nerves: the auxiliary, the radial, the median, the musculocutaneous, and the ulnar nerves, and that innervates the arm muscles. So you can see here's the cervical plexus, is up at the top of the neck, and then the brachial plexus is about in the middle to the bottom of the neck and the top of the shoulders. The lumbar plexus, which is right in here, is going to innervate the lower abdominal region of the anterior medial thigh, the buttocks, and the small hip muscles, and that is located at the central rami of the L1 through L4. So the lumbar nerves in through here. And then there's also the sacral plexus at the L4 through S4, and that innervates the buttocks, the posterior thigh, and virtually all of the leg and foot, because it is right here, and so it's going to handle everything below. There's 3 layers of the eye, which you can see are drawn up here. There is the outer portion of the eye that consists of the cornea and sclera, and that is transparent, or the cornea is transparent, which allows light to enter in through the pupil and protects the iris and pupil from potential harm. So that's right here, and it's going to protect basically all of the inner portion of the eye. The uveal tract consists of the iris, the choroid, and the ciliary body. Not the greatest at pronouncing, but that is going to be right here, and that protects and works together to control the amount of light that passes through the lens into the retina. The retina is at the back 2/3 of the eye, so that's back here behind everything else, and that is the photoreceptor layer that takes light and transforms it into the interpretations that we see as the world around us. There's 3 divisions of the ear, as you can see I drew down here, and that consists of the outer ear, which functions are the external portion, which collects sound waves and directs them into the inner portion of the ear. So here would be the outer ear, all of this, and it's going to direct everything in towards the middle and inner portion of the ear. The middle portion of the ear is between the eardrum and the oval window, which transmits sounds from the outer to inner ear. So here'd be the middle, and it's going to transmit sounds from the outer into the inner. The inner ear consists of the cochlea, and the balance mechanism, vestibular and auditory nerve, and this sends sound impulses to the brain. So here would be the inner portion, which sends the sound impulses up into the brain. For the general structures of the taste and smell, here is the tongue and then the nose structures. So the taste occurs when molecules are dissolved in fluid and reach the gustatory receptors on the on the tongue, and send signals to the brain to determine flavor. The taste buds are found on the tongue and contain many clusters of gustatory receptors on papillae, which also have receptors for pressure and temperature. And then with the odors, it's all going to be in the olfactory bulb and the nerve ending, so it's going to come through the nasal cavity, and with these nerve endings in the olfactory bulb, it is going to be read by the brain to tell you the different odors. The automatic nervous system imbalances can create problems and failures in our body because it alters the homeostatic nervous levels in our body systems and creates problems such as dizziness, inability to alter heart rate, orthostatic hypotension, and the list just goes on. So basically, any changes or imbalances in the automatic nervous system is going to completely change all of these different structures that I just talked about and is going to mess up everything in the body.